Lealis po ko lang ng, for today's discussion, I will be tackle the Pascal's principles. So, Pascal's principles states that any change in pressure applied to a completely enclosed fluid is transmitted and diminished to all parts of the fluid and the enclosing walls. So, the key word here is what we call enclosed fluid. So, this phrase. So, this means that our fluid is placed in a confined container, which means dili pwede mo sulod ang hangin, so ang liquid lang within that container. So ang Pascal's principles states that our pressure in one confined liquid is just the same all throughout. So we have here the two Pascal's principles. So first we have the Pascal's first principles. So according to this principle, the force at any point inside a fluid to the pressure that point acts with the same magnitude in all direction. So the direction is important here. So as a consequences of the direction, the force in the walls of the container due to the pressure of the fluid is perpendicular to the wall. So next, Pascal's second principle. So according to this principle, when pressure is changed, increase or decrease at any point in an incompressible fluid, the pressure at all other points in the fluid changes to the same extent. So the key phrase here is change in pressure. So often, the second principle of Pascal is also referred to as the Pascal's principle. Okay, note that this principle does not say that the pressure is same at all points of a fluid, which is certainly not correct, since we already know that the pressure in a liquid varies with depth. This principle rather addresses the change in pressure. So next is we have the hydraulic lift, a device that uses a confined fluid to transfer pressure from one platform input to other output. So our hydraulic lift, we actually see it in our car shops. So this is the equipment that's been used to up the cars that is needed to be repaired. So here, we use a small amount of force that the car will moving upward. So, the pressure that we created in our input is also the same pressure that we create in our output. Okay, so we know that the formula for pressure is force over area. So, diri nato ginakuha ang equation of Pascal's principles. Okay, so let's take this a problem. So, a 2,000-pound car is lifted by a manually operated hydraulic lift. The area of the shaft of the lift is 80 square centimeter. The area of the piston that forces liquid into the system is 2 square centimeter. So, what force must be exerted on this piston to lift the car?
So let's identify the given. So we have F1, A1, F2, and A2. So if we assume that our input is the A1, then our output is A2. So let's identify the problem. So our 2,000-pound car is mauni ato agamiton for F2. And then we have the area of shaft. So the area of shaft, which is the car, placed in 80 square centimeters. So this is our output. And it says that the area of piston is force liquid into the system. So this is our input, that is 2 square centimeters. So let's put it here in A1. So the question is, what is the force must be exerted on this piston to lift the cars? So, in this case, this is what we gotta find out, our F1. So, let's use Pascal's principles. So, the formula is we have F1 over A1 equal to F2 over A2. To solve the F1, so let's cross multiply. So, F1 A1 is equal to F2 A2. So, since we solve the F1, we need to divide both sides of the equation by A2. For us to cancel A2 here in the left side. So now we have F1 is equal to F2 A1 over A2. So substitute the values. So for F2, we have 2,000 pounds, and then our A1 is 2 square centimeters, and divide it into our area 2, which is 80 square centimeter. So the area 2 is 80 square centimeters. So if you can see, we can cancel the unit of square centimeters. So ang mabili na unit na lang is pounds. So therefore, our F1 is equal to 50 pounds. Okay, so let's take this video presentation so that we can deeper more understand about Pascal's principles.
Pascal's principle states that pressure applied in a confined liquid is transmitted uniformly in all directions throughout the liquid. Let us learn this through an experiment. Take a tube fitted with a piston. Attach a rubber balloon at the bottom of the tube fitted with a piston. Fill the tube with water. Pierce some holes in the balloon. Push the piston downwards so that the pressure is exerted on water in the tube. You will observe that water comes out with the same force in all the directions from all the holes. We get down to the conclusion that if the liquid is trapped in a container and pressure is applied according to the Pascal's principle, this pressure will be transmitted equally in all the directions, and the water moves out from the holes of the balloon with the same force.
Okay, thank you so much for watching, guys, and I hope you learned something from my discussion. It's all about the Pascal's principles. Thank you and have a good day.